So we will continue today the second 2 hours, and we will talk today about surface water and groundwater resources. Also, we have an example. We will move later to the GIS lab. Actually, as I mentioned yesterday, that soil, one of the natural resources, and natural resources is one part under the environment. As environment, you know, one corner of the classification of sustainability. We have society and economy and natural resources or environment. So biodiversity and natural resources is one of these classification. And water, surface water or groundwater are one of these resources as well. So we will talk today about surface water and groundwater resources. Actually, I will start from very simple information, and most of you, all of you know all of this information. And step by step, I will go to the next information. First, I will talk about what is water, and secondly, we will talk about what is hydrologic cycle of water, and thirdly, we will move to the third part, which is what is surface water, and when we will get the idea about what does mean surface water, we will move to the meaning of groundwater, and then we will move to the surface water and groundwater hydrology, what is the relationship between them, and finally we will move to the groundwater and climate change. This is the issue of nowadays, as one of your colleagues mentioned yesterday, that the sustainability nowadays is like a fashion. So news, layman, all the people are talking about this issue. So we will connect the third corner of sustainable classification, which is environment, and one part of this environment is natural resources, and one part of natural resources is groundwater, how groundwater affects climate change. And finally, we will watch 3 videos, and we have a link of carbon emissions. I believe that you will like it. So, as you know, that water body cover almost 70% of the surface. Only water as stands exists naturally on Earth in the 3 physical states of matter, gas, liquid, and solid. And this is the connections between the atoms of oxygen and hydrogen according to the physical states, if it's solid or liquid or gas. So you know that the Earth has liquid water as oceans, as well as has regions covered by solid water as snow in the polar areas. This is the basic idea about the water. So let's move to the hydrologic cycle of water. So here in this figure, as you see, are seeing here that we have many kind of operations or hydrologic cycle of water. So we have the evaporation, and then condensation, and then the movement of clouds, which is called advection, and we have the rain, which the water will come back to the ground, and then we have sublimation with the transfer of snow or ice to evaporate without to pass in the physical matter, which is liquid. As well as the movement of water in the ground or under the ground, it's also a bit connected, because if we will take just 1 minute and think about the huge amount of precipitation each, let's say, each winter or each year here in Finland or in any other country. So where all of this water will go? Is all of this water will evaporate or will be percolated? I mean, will be infiltrated. So much of this water will be evaporated, and the other will be in runoff on the ground, and the other water will be percolated to raise the groundwater level. This topic we will talk about in the next slides. So the storage of water and the movement of water, it is between the biosphere and atmosphere and lithosphere and hydrosphere. So the water will be in the ground, will be in the lithosphere and hydrosphere. However, when the water will be inside the plants or inside any body of organisms, if it's a human or a very simple species of insects, so it will be like a biosphere, or might be in the atmosphere as evaporation. So, as I said, we have two kinds of water. The first one is surface water, and the second one, and it's very important in many dry area, which is called groundwater. So any kind of water on the surface, on the ground, it's called surface water. However, we have three types of surface water. The first one is permanent, or it's called perennial, and the second one it's semi-permanent, or it's called ephemeral, and the last one, which calls man-made. Actually, this man-made I have seen in, during my MSc work in the western part of Iraq, in the desert. So the people in the desert there, what they are doing, or what they were doing at that time, actually they excavate in the desert a big basins. So they accumulate in these basins the rain, most of the rain during winter. And later on, they during summer they exploit this water for animals drink, or sometimes for human use. However, from the name, so all the water underground. The source of this water, most of these water sources, is precipitation. We have two parts of this groundwater. According to the saturation of water, we have unsaturated zone. If the voids, the void means that all the spaces between the grains and gravel, sand, silt, clay, and cracks within the rocks, if it's contain air and water, so it's called unsaturated zone. Actually, this water cannot be pumped by wells because it's held too tightly by capillary forces. Capillary forces, I think most of us, we did the blood test. When this a very small tube, they just make pin on the skin, and then they take blood, and the blood actually will move quickly in this a very micro tube. So this is called capillary movement. If you studied before physics, so I believe that you know it. So because of this capillary movement or capillary forces, that it's not possible to pump this water. Other part, we have saturated zone. This saturated zone, that means all the void, all the spaces are filled by water. And this type or this kind of water, it's possible to pump it and use for irrigation or using for drain or any kind of use. Actually depends on the quality of the water, I mean chemical quality of the water. So the relationship between surface water and groundwater. We mentioned in the first slide here, we mentioned that the hydrologic cycle of water, so each state or each physical state of water is connected to the other state. So the evaporation, I mean the water in the sea or ocean or any kind of water is connected to the other parts, are connected to the groundwater through this cycle. So the surface water commonly is hydraulically connected to groundwater. But actually it's difficult to find the interactions between surface water and groundwater in many areas, especially in dry areas. For instance, this area, as I mentioned, in the western part of Iraq. So we have, from the right side there, we have Euphrates River, and from the other side we have desert. So it's not possible to find the real connection between this river and between this desert, because when you just cross over the street and then walk almost 1 kilometer, you will find yourself in desert. Everything, no agriculture. It's a really dry area. However, in the side of the Euphrates basin, you will find the other area, agricultural area, and actually it's it's really difficult to find the connection between surface water in this area and groundwater in the other area. As I mentioned shortly before, that the amount of water actually is you could find it in many physical states. You could find it in the plant. You could find it in our body, in animals' body, in any kind of organism. Because actually, if there is no water, all of us we know this, there is no life. Let us talk about now about how the groundwater, which is not surface water, I mean the water underground, how this water affects the climate change. Actually, any change in surface water like rivers, lake, wetland, affect the climate change in two ways. However, I would like to mention to you that what does mean climate change and what does mean weather change, because many people mix between these two scientific terms. If we talk about the temperature today, for instance, or the temperature last winter in Turku, or if we would say that last winter was very cold in Turku, that means we are talking about weather change. Short term, it means weather change. However, if we say that last 10 years in Turku, the amount of precipitation was 20 centimeters. That means we are talking about long term, which give a sense to us that we are talking about climate change. So weather change, that means we are talking about short period. When we're talking about long period, that means we are talking about climate change. So the groundwater, how the groundwater affects climate change, I mean affect the long term of weather, depends on 2 points. The first point is change in the volume and timing and intensity of precipitation. So this change will affect the amount of surface water and then affect the amount of groundwater. Also, change in temperature, radiation, atmospheric humidity, and wind speed. All of these items affect the groundwater level, and then affect the climate change. How it affects the climate change? Because if it's very simple example, in my study area in Greece, during the last 40 years, in the middle of Greece, the capital, most of you know it, the capital of the middle of Greece, it's called Larissa. So this area, all of this area are affected by ground deformation because of a huge water pumping in this area. So there is no enough water, or the precipitation it's not enough to irrigate their agricultural lands. So what they are doing there, they are using or pump the groundwater. So the pumping of groundwater, the climate change affect the groundwater and somehow, and then the people pump this water and then affect the sustainability. Oops, sorry. Actually, groundwater is generally more slowly respond to climate change than surface water. Because, as I said, the main source of groundwater is precipitation. As I mentioned, a very simple phrase that imagine that this huge or tremendous amount of rain each year in any place you have been before. Where all of this amount will go? If it stay in the surface, that some kind of fluid will occur. So most of this water be percolated and increase the level or raise the level of groundwater. However, groundwater level, it's slowly affected by temperature, because the temperature hasn't any direct impact to the groundwater. However, the temperature affects directly the surface water. Actually, we have this. I don't like to go more details in the what does mean aquifers, but it's just generally. Also, I connected this issue, the issue of nowadays as well, the dioxide carbonate emission and how it affects the climate change, and also how it affects the evapotranspiration. Evaporation, you know, from any surface of water, it's called evaporation. However, the evaporation process from the plant, it's called evapotranspiration. Let's go to see the carbon emission. I think this doesn't work. Okay. Let's take this link and so this is a very nice example. So this is actually some kind of time series of the dioxide carbon emission. So how this case is developed and affect the climate change, as well as affect the sustainability and affect the life of people. So the history, look at this, how it's a human impact so far, from zero emission of dioxide carbonate to reach to the other level. Let's see. So I will read directly from here some lines. When our human actually they have very limited impact on the nature. So there is zero carbon dioxide emissions, and there is no any impact or effect on the climate change. However, the development and when the humans started to use the resources and cut the trees of forest and uses in some kind of daily life, so they affect in somehow the environment. As well as in summer, in Iraq. So when they, at that time when they invented the wheel, enables humans to move to heavy loads and to make some facilities to people. So take a look here that how is the development and the human affect the sustainability and affect the environment. So Western Europe enters a machine's age powered by coal. And then from coal to the engine creation, and to the more increase of emissions, carbon dioxide emission. And then many development, many effect many bad effect to our environment. Reaching to oil pumping and use oil as a fuel, so they affect our environment and the sustainability. We have just two things. We have the, as I said, we have the environment as the third corner of sustainable classification, and this one thing affect this environment. Look here at the increasing of carbon emission. The development and the constructions increase the carbon emission. Also, the Ford or the car manufacturing and deploying these engines of affect or increase the carbon emission, reaching to the airplane and then to the urban sprawl, and then to this point of the human activities and the discussion of why the carbon emissions is increased. What I would like to say from all of this, that the amount of carbon dioxide emissions, a huge resource of these emissions is occurred by a human effect. As we mentioned before, yesterday, if you remember, that development nations affect the sustainability. So, how the development nations affect the sustainability? Affect the sustainability in a way of increasing manufacturing, of increasing using oil and using all the fuel, I mean chemical fuel, instead to use, for instance, solar energy, or use air energy, or all of this kind, also the tide energy in some kind of countries would have a big coastline. Now, as yesterday, we have 3 videos So the main source of groundwater is precipitation. And this one kind of connection between surface water and groundwater. And this is the process of water pumping, how it affects the level of groundwater, and then after many years how it affects the surface water. And the second one,
we all know the Earth is full of water, but there's a lot more to water than all that blue stuff you see on the globe. The water we can see on the surface of the Earth is surface water. Surface water is every lake, pond, river, stream, and ocean on Earth. But in the ground below your feet, there's even more water, groundwater. Groundwater is water that's crammed in the tiny gaps between rocks, soils, and sediments under the ground. A full body of groundwater is called an aquifer. There are huge aquifers all across America. The biggest is the High Plains Aquifer, which covers 174,000 square miles right in the middle of the country. Anything that big deserves a closer look. Let's say you could grab a shovel and dig straight down through the soils to an aquifer. The level underground where you first hit groundwater is called the water table. Below the water table, the ground is completely soaked or saturated with water, which is why this area is called the saturated zone. The area above the water table is called the unsaturated zone. So, how does all this water end up in the ground? Well, it's all a part of the good old water cycle. When it rains, some water gets soaked up by plants. Some water runs off the soil and into streams, lakes, or even the ocean. Other water gets stuck on the surface and eventually evaporates back into the air. Meanwhile, some of the lucky water droplets get to travel down through the surface deep underground until they reach the water table and become a part of an aquifer. Once water seeps down deep enough into the ground, it can stay there for a really long time. Some of the water stored in the deepest parts of aquifers has been there for thousands of years. But after it gets there, groundwater doesn't always stay in the ground. A lot of the water on the surface comes from aquifers. If the surface of the ground dips below the water table, groundwater flows out into the space, creating a body of surface water. If the surface water dries up, groundwater can flow in to fill it back up. And if the water table in this area rises, so does the level of the surface water. Groundwater can also pour down a sloping surface, creating streams. Any place where groundwater flows out into the surface is called a spring. Surface water can also become groundwater. If a body of surface water flows above the water table, water can seep down through the sediment and help fill the aquifer. Of course, there's another way that groundwater can leave the ground. Us. Humans depend on groundwater, and there are thousands of wells all over the country that draw water out of aquifers. In many parts of the country, the water you get from the tap comes from the ground. However, we use most of our groundwater to help grow the food we eat. Farms can get lots of the water they need from rain, but rain isn't always enough. And in dry years, farmers depend even more on the water that's stored in the ground. In fact, American farms use about 53 billion gallons of groundwater every day. That's enough to fill over 1 million bathtubs or 80,000 Olympic-sized swimming pools. So, if we're using that much every day, can it run out? Well, yes and no. Remember, aquifers can be refilled by rainwater or surface water seeping in from rivers and streams, so there's usually more water on its way to replenish the aquifer. But if we use groundwater faster than the aquifers can refill, we could drain them dry. They probably wouldn't be empty forever, but it would take hundreds of years for the largest aquifers to get back to healthy levels. Whether it's up here or down there, water and how we use it matters. We may not be able to see it every day, but groundwater makes our lives possible. So don't let show-offs like rushing rivers and roaring oceans get all the attention. Those unseen aquifers below ground have been here longer than we have, and with a little love and care, they'll keep on taking care of us long into the future.
And we have the last video, and then we will move to the GIS lab and we will discuss there.
You know, my lunch was produced using groundwater to sell vegetables are grown locally, and soda ash is used in the glass in the wine bottle and also used in cement for this building. If I look down at Adelaide's urban landscape, I can see parks, gardens, schools, all of which use groundwater to irrigate their ovals and keeping our city looking beautiful. In my work as a hydrogeologist, I need to understand Adelaide's groundwater resources. We need to know how much there is, where it occurs, and its quality, so that we can advise government and industry on the best uses of that water. Traditionally, we think of Adelaide receiving much of its water from the Murray and fertilising our hills catchments. Yet down there on the Adelaide Plains, groundwater plays a major role in feeding our city, watering our gardens, sporting grounds and schools, and is an essential in establishing and driving industry. Groundwater is exactly that. It's water from under the ground, which is stored in aquifers. Aquifers are sediments and rocks which can hold and transmit water. The water flows into tiny pore spaces in the sediment or rock, or in some aquifers through cracks and fractures. This flow is very slow, not the way rivers flow on the surface, but much slower. The aquifers in the Adelaide Plains are known as sedimentary aquifers. They were formed over time from the accumulation of sediments from marine deposits and ancient rivers. Aquifers are mostly filled or recharged through rainfall that seeps down through the ground, but recharge may also occur from the lakes of creeks and streams to shallow aquifers, or leakage from aquifer to aquifer. Over to the east are the Mount Lofty Ranges, and this is the source of much of the groundwater that's found in the deeper sediments on the Adelaide Plains. The rain that falls on the ranges today infiltrates through the fractures in the rocks, down through the sediments and to the gulfs and fences. It takes about 17,000 years for a drop of water to make this journey. We access groundwater by drilling into an aquifer and drawing the water up via a pump. The Adelaide Plains have a number of aquifers. These date back in geological time, 100 million years, periods known as the